name is Israel. I came from Spain. I am currently working at Corologics as software engineer. Very likely you don't know what company is Corologics. It's a company about observability. What is observability? You will learn during this talk. Sorry. And well, also I am contributing to different projects, mainly to OpenTelemetry, and I'm part of different community programs like the Google Developer Expert from Google and well, other things, right? Okay, so today what we are gonna talk is about cloud applications, especially about problems, right? Everybody talks about how amazing it's working on the cloud and developing software and everything, but I came for the hard part, right? For the problems. So very likely, well, I hope you know Python because you're here. But maybe, right, your services, this will be pretty nice, right? Because it will be like just for services, right? But maybe your applications look like something like this, right? You have multiple applications that are interconnected between them using different languages, like JavaScript, I hope no, C, C++, Golang, Java, I also hope no, especially if it's Java 5 or something like this. It's deprecated, please stop using it. Let him die. And yeah, well, so it's like you have to manage different things, right? Maybe you are not necessarily a site reliability engineer, but maybe you have to do everything because, well, it's how life works, right? And the thing is that, well, when people talk about microservices and things like that, right, they forget about the different problems, right, that you have to deal with. It's not just that you have to build that Java 5 service and these kind of things, but also things like, hey, the network is reliable, right? It's going to work properly always. Latency is 0. The bandwidth is infinite. The network is secure. Topology doesn't change. I mean, like, you have applications, right, that before they were calling this service, and now they are calling this other service, and a new service appears, right? Another dies. They remove one database, things like this, right? There is just one administrator, right, that knows everything. But people also like going on vacation and being sick. Well, they don't like it, right, but they get sick. Things like that, right? So you have multiple people touching things, even if your company is small and things like that, right? Also, transport costs 0. If you go to, for instance, Twitter, X, whatever it's called this day, you will find a lot of people complaining about the egress and ingress in AWS and things like that, right? And also things like the network is homogeneous. Things like, okay, there could be things that are here in your network, right, in your cloud, but maybe you have, I don't know, multi-region, right? So you need things from one region to the other. So there is something in between, right, that it's not going to be as good as the internal network that you have in your cloud and things like that, right? So it's the kind of things that you have to take into account. And also, very likely, you are going to be serving to different customers, right, or clients or whatever, that they are going to be using maybe 3G connection, right, or something like that. Okay, so the thing is that you very likely have a stack like this, right, where, well, you have the bare metal, the component stack, and Kubernetes, very likely managed by AWS, Azure, Google Cloud, whatever. And maybe you had to manage, or your SREs had to manage the containers, right, and the application, I mean, like deploying it, right? Where they are facing the bugs, the fires, the alerts, different kind of things, right? If we take into account all the problems that we were having before, all those changes in the network and these kind of things, it's like you have to be monitoring everything that is happening, right, in your system, in your application. And also you have to manage things like, if you are taking into account things like security, right, you will need to manage things like the certificates and these kind of things, right, and also certificate rotation and these other things. And maybe this person who is using, this team that are using, I don't know, something like a library for doing this kind of certificate management or whatever, right? And these others are using this other because it's a different language or just because they don't like the others or something like that, right? So it's like, this is something that Service Mesh tries to address. What is a Service Mesh? It's kind of another layer. So we were seeing this, right? So it's like another layer that we are going to add to our stack, where we are going to be like facilitating the communication between the different services. Okay, we are going to place something in between that is going to facilitate that communication, usually a sidecar proxy. So how does it work? Oh, well, actually, let's going to talk about Istio, right, to be more like specific about something, right? Istio is open source, was created by Google. It's part of the Cloud Native Foundation since 2022. And it's like almost, I would say it's almost the standard, right? If you go to the different providers, very likely the different providers for service mesh, very likely they are using Istio, right? There are others, but it's like, I don't know, maybe the 90% on the industry are using this. Okay, so how does it work when you don't have a service mesh? So let's imagine, right, you have 2 containers and you have to send a request from service 1 to service 2. So you just send the request, right? It's fine. Okay. You get an answer or not or whatever. Okay, something's going to happen. With service mesh, in the case of Istio, what we are going to do is that we are going to add for each one of our containers, we are going to add, or actually for our pods, we are going to add a new container that is a proxy. In this case, an envoy proxy that is like going to be intercepting of the communication. So it's like when you want to send, you receive a request, right, and it goes to container 1. The request actually goes first to the proxy, later to the container 1, and later when you want to send something to container 2, it goes again through the proxy, and you call right to the container 2. So with that, it's like you can measure right what is happening in the traffic there. You can also like modify right the request, add security, and do other things. So more or less, this is how one application will look like, right, when you are using Istio. So it's like you have here something like a gateway, right, an entry point for the service mesh. Well, you will be doing queries to different services, but as you can see, every single pod has different services have this proxy, right, that will intercept the data. It's like doing a man in the middle somehow. And also you have something, right, that is going to be managing, right, the Istio infra, right? So it's like going to be injecting those proxies and doing other things. Like, for instance, sending data, right, to some dashboards so you can like manage and know what is happening inside your mesh, right? The things that this is something that has been changing, right? It was launched at some point, right? And now they launched, like 3 years ago, they launched something called ambient mesh that is like pretty hot on the industry right now. And it's like, before, right, we were adding this sidecar. So now it's like, let's remove the sidecar. And how are we going to manage the thing? So it's like before we were managing the things at the layer 7 of the OC model, right, at the application level. And now it's like a lot of things were moved to layer 4. How? Using this eBPF thing that very likely you have heard a lot about it. But it's something where you can create like modules and insert them, run them as part of the kernel, right? So it's like this sidecar that we were having before, like a separate container, now we are going to be able to have it like injected in the core, more or less, right? It's not exactly this, but just to give you one idea. Some features that you can use with like service mesh enable you to have things like doing canary releases, right? So you don't have to be like managing them like manually or something like that. Blue-green deployments, A/B tests, traffic mirroring, right? So if you are sending, for instance, data to one service, right? You can send also those requests to other path or route, right? So for instance, if you want to do some kind of debugging, you can know exactly what's your different service sending, right, to between them. Also increases the resiliency, like adding circuit breakage. Like for instance, if you are doing a request to a service and you know that service start to fail, right? I don't know, 10 requests per second, right, are failing from 100 or something like that. So at some point, right, you say, hey, I'm gonna cut here the request, right, because I am wasting resources trying to do that request, right, and to that service that is totally down, right? So it's like automatically it will return directly one error, right? So you don't get the results, the time to do the query, to these kind of things. Also, you can implement automatically retries, timeouts, inject failures, because maybe you want to test something in your infra, right? And hey, what will happen when we have this kind of error, right? So you don't have to code one error and deploy it, right? So you can directly inject it from here. And also things like, well, traffic encryption, mutual TLS, and these kind of things. This is great because now you don't have to implement this on the different libraries, on the different applications, right? Using and maintaining the different libraries that very likely you need to maintain for the full company. So it's like you extract and you delegate those things, right, to a third party, let's say, right, to another layer of the infra. And now it's like your applications don't have to care about security and these kind of things, right? So you can enforce and do everything from here, like automatically, which is great, right? Because doing things is much worse than doing nothing, right? So now you have to do nothing when you are developing. And we are going to focus a little bit more about observability, mainly because it's the thing that makes me have at this every day, right, on top of the table, and I have to talk about observability. What is observability? Just if you were not here last year with me, or the other day there was a great talk about OpenTelemetry. Observability is like a way, right? A system can be observed when you can infer the internal state with some outputs, right? So it's like we send a bunch of data to an application, another application, right? And that will provide some insights, right, about what's happening, right? Usually, what do we send? Metrics, like, for instance, how much memory we are using, or how many requests are failing or going well, or things like that, right? Logs, you know, that thing that you are printing, like, hey, my code reached until here. But serious logs, right? Like, hey, I failed to write on the database or to open this file, or now I'm unable to do this other thing. And traces. The case of metrics, right? It's like pretty well known because it's like what we have been doing for monitoring, like for ages, right? I mean, like you can create alerts like, hey, the number of nodes is increasing dramatically, so your cost is going to be pretty high. Very likely you want to take a look, or the service has not been responding in the last, I don't know, 3 hours or something like that, right? Logs, we know because very likely it's the first kind of observability that we learn when we are learning to program, but traces is a little bit tricky. So we're going to talk a little bit about traces just to give you some idea. And I like to explain this with the free docs problem. Why? Okay. What is this doc doing? Sit, right? This other is up, right? Come on, let's be a little bit more interactive. Minus interactive mode, please. And now, apart from that, it seems that he's down, right? So, okay, this is what happens when you have microservices and you are just checking the metrics and logs from the different services. You don't know how the full thing is going. So this is actually how the dog is doing, right? So now we know exactly what's happening from the end to the end, right? So now it's like we can create something, right, that will provide us some kind of graphs about what's happening in our services. So with this, you can see, for instance, that we are having a call, right, to service A calls to B, it calls to C, right, and when we end, we call to D, and when we end, we call to E. Even we can generate a Gantt chart when we know not just the relationship between the different services, but also we can measure how much time we spend on the different services. So it's like we are doing kind of profiling, right, for the full request, which is great because sometimes it's like, I know that something is failing, right, but let's imagine you don't have like 3 services, right? Maybe very likely you have 200 of services, right? And you are seeing the user that something is failing here, right? But very likely it's not like the first thing that is failing, right? It's like something in the middle. So how are you gonna find it, right? And when you are like wake up at 3 a.m. to fix something like this, right? It's like you want to find it pretty fast because the company is losing money, right, at that point. And well, this is, for instance, in the case of Coralogics, right, there are other many, you are gonna see one other backends, right, but this is something that you can get, right? So it's like pretty easy. If there is a failure, like for instance, we can see, okay, no, there are no failures here. We did pretty well. So for instance, you can see right how the different interactions between the services went, right? So it's pretty easy to see exactly the things, right? And even you can get data. For instance, the data that you try to send, the method, it was HTTP, gRPC, or something like that, right? So it's great. So it's like, with this, we are able to see exactly what's happening in our service. With the metrics, if there is a problem. With the logs, what is exactly the problem. And with the trace, where is the problem? Okay? Nice. In Istio. So the thing is that there is something that is called Kiali, and it's developed, it's driven by Red Hat, right? It's kind of a UI for service mesh. It allows you mainly to do kind of observability, also to do some configurations, but mainly to do observability, right, for the different services in your mesh, right? So what I'm going to show you is a small demo application. It's not, I changed it a little bit for this conference. I will upload it later. But it's something that I have been, there is here a tutorial just in case you want to test Kiali and all the problems that you have when you are using service mesh, and we will see it later, how to fix them. Okay, so what we are going to see, it's like, this is Kiali. This is Kiali, okay? When you open it, and we are going to see that we have one demo application running, right? So one of the things is that we are going to go, we have, these are the different namespaces, the different things that we have running in our cluster. So if we go to the application that I don't know why started to fail, demo effect. Okay, so now, if we give it a little bit more of time, we are going to be able to see the architecture of our application, right? In this case, I didn't have to modify the code, okay? What I am doing is just doing some requests. And we can do pretty nice, interesting things. Like, for instance, we can enable some metrics here. We can see exactly what is happening, the response time, right? We can see it here. Something that, also the distribution of the traffic, right? Something that I love is this, the traffic animation. Managers also love this part, right? Because managers love moving things in screens. So this is great, right? And we can see here that there is a problem right here in this service. Okay, I don't know why this thing is becoming crazy. Give me a second. It worked on my machine before. No, to be honest, I have been doing this demo many times, and this is the first time this happened, so I don't know why. Okay, so the thing is that you can see the thing, right? And even you can get some metrics about what's happening here, right? Give me a second. I think it's because of this random thing that I have to run here because of something on my machine. Okay. Well, something even that you can do is to replay, right, how the traffic look like. It's not working because of this problem that I have here, right? But it's like at some point you have the idle nodes, right? You can see, you can reproduce what was happening, right, in your, like the communication on how the infra changed and everything. And you can see other things like metrics and, well, different things. And one of the interesting things is that automatically it will generate some traces for you. So you can go to Jaeger, that is one of the backends that you have in this thing, right? And you can search for the traces. The thing is that when we go to the traces, you will see that, for instance, in this case, right, we have from the gateway to application 1, but we don't see application 2, 3, 4. If we go to application, for instance, 2, we're going to see that there are some kind, like, we are not seeing the full transactions, right? And this is because this was just in case there was a bigger demo effect. So you can see this kind of stats and metrics and everything generated automatically, right? But by this tool, even you can get here. You can get these metrics, right, in your workloads and everything, and you can get here your traces, and you can get even how much they are taking, right, to run. These metrics that are called RED metrics, request, endurance, and duration. No, request, error, and duration. Or in Google SRE book are called golden metrics. So the thing is that they are broken, right? So the problem is that there is one standard or something, right, that tells you how to propagate context. Because in metrics, right, since we are, since we are in service 1 and service 2 and service 3, right, it's like you have to propagate something to let the system know, right, that this is the same transaction. So it's like you have to propagate these headers at some point. So the thing is that you have to do it in the code, which is not good, right? Because I promise before that you didn't have to change the code. I am not a liar. I am going to fix it later. So now we have the full transaction, right? Now that we are propagating those headers. So it's like now, right, we can see where my application is failing and everything, right? And well, if we have some kind of logs or something, right, and some kind of data, right? The method, as I showed you before, I mentioned before, right? You can see things like the component, the kind of method that you use, from where to where, these kind of things. Okay. Okay, so the thing is that there is something called OpenTelemetry, that is where I work. It's kind of an observability framework, mostly for gathering telemetry data. And it's like, it cares about the generation, exporting data, and everything. So you don't have to change what you have right now, right, to use this new thing, right? But it's like you can do processing of the data, and if you want to change to a different vendor or something like that, it's pretty easy, more or less. So the thing is that one of the things that it has is the operator for Kubernetes. I don't know if you are familiar with operators, but it's something like allows you to automate some things, right, with another layer of abstraction. So one of the things that it has is something called auto-instrumentation injection. And it's something that allows you to inject some libraries to your workloads, and you can inject also the way to propagate the context. So it's like, if we do we apply this object, right, that is like the instrumentation, right? It's something that tells Kubernetes how to inject the instrumentation libraries. And we do our start application, and now we are not forwarding the header like we were doing before. It will take a while. Moment, 1 second. I don't know actually if I did. Okay. It can take a while, but I think now should be fine. Let's see. Oh, okay. Now, without propagating that context manually, we have the spans being created properly. So now the thing is also that, as you can see now, we have more spans than when we were propagating manually the context, because the thing is that we are injecting this thing for the request library, for Flask in this case, and other libraries, right, that we are using. So it's like we are generating more spans. So we are getting more information for free. And we can see all the information there, right? So for instance, we can see here, right, that this was a request. This was a request. This is the library from OpenTelemetry that we are using with this version, right? And it was done by the auto-instrumentation library for requests. Even we can, we go to Kiali, and we go here. Now we can see that we are sending that data, right, to one OpenTelemetry collector. That is like one application that you run there to collect the data, do some kind of processing, and send it to somewhere else, right? Well, we are going to be seeing this. This is a comparison, right, about what we were getting before and what we are getting now, right? And you can see that there are more spans. Well, to end, running stuff in Kubernetes is not easy. It can be fun, but usually not. Yeah, actually it's fun. Service mesh also can be a great tool, because very likely, right, you read about service mesh and you became like pretty, how to say, pretty hype, right? Oh, this is gonna solve all my problems. But as you saw, right, it's like you had to sometimes complement with other things, like for instance, OpenTelemetry, it's a good fit for this thing. And also sometimes, since at the end of the day, right, you are adding a new layer of abstraction, right? So it's something that also can fail. Is pretty well beta tested, but it's also something that can fail, and also you need to know how to configure it to get the full thing, right? So yeah, you have to learn about it. So I hope you like it. So I mean, I did many demo things, right? So I expected at some point something like, whoa, working right or something. But actually, you are a pretty difficult public. It's fine. Thank you so much.
Thank you, Israel. If anybody has any questions, please come up to the microphone. It's over here. Oh, we have somebody.
First of all, as Sean Connery would say, what a mesh. I actually have a question. Common problem in my company is that we are chasing 500s, and it can happen anywhere from the Python application code through, kubeproxy, whatever, Envoy, Istio, Kong, and load balancer. Do you think that OpenTelemetry would be sufficient to sort of point you at, hey, where is this 500 coming from, at which layer, or is as a sort of like resolve to just chasing the rabbit over the layers myself?
Actually, that is not a part about OpenTelemetry itself, because the thing is that the problem is an instrumentation problem that can, I mean, sometimes the instrumentation problem comes from the libraries that you have, right? In this case, the OpenTelemetry libraries, right, that you have injected, but other times it's like also how the application itself was instrumented if somebody added some kind of instrumentation, manual instrumentation. So for instance, in the case of the proxy, right, we are not modifying anything here. So if you want to debug something with the proxy, it's like you have to rely on the logs that the developers added to there, right? It is enough. I know companies that are running this on production. Even I think, yeah, there is a link, right? I mean, there. One of the links is to one blog post that I wrote pretty recently about, I mean, in our company, right? That actually is just a resume about this, right? Like in 1 week or something like that, after writing it, right, we were having questions because are people running this on production, right? With this setup. Mm-hmm. So yeah, isn't that is enough?
Okay, so instrumentation is key in here. Okay.
Yeah. The good thing here is that, since I mean, most of the people don't want to modify anything on their side, right, to add instrumentation. So this thing adds instrumentation for you, right, and that's it for you. I mean, even the metrics thing, right? So you are getting everything on that side for free. So yeah.
Any more questions? We have another couple of minutes. Okay, can we give Israel another round of applause, please? Thank you very much.
Thank you.